Video, I'm going to be going through the end behavior of a function, and what I want you guys to do is just kind of focus on learning how to write this, because end behavior of a function is incredibly straightforward to see and identify. The trick is just learning how to write it. Alright, end behavior in layman's terms is the way we discuss the arrows on the ends of a graph of a function. We're going to be working with polynomials, as we have been doing throughout the entirety of this chapter. These have pretty straightforward end behavior, nothing terribly crazy here. The hardest part of end behavior is learning how to write it. That's the hardest part. Seeing what it is and identifying what it is very, very straightforward stuff. It's learning how to write it. Even if you forget how to write it, you should always use words to express something. So even if you just write out with words what the end behavior is, you know, there's some serious partial credit points in there. Alright, so given this function, we need to state its end behavior. Alright, so we start at the middle. So I'm going to almost put my finger there on the black dot, and I follow the function all the way to the left, and then all the way to the right. So let's start by going to the left. Well, it looks like this arrow here is going down. So, as x goes to the left, then f of x, which is a fancy word for y, goes down. So basically, as the black dot goes to the left on the x-axis, it goes down on the y-axis. Alright, same thing. So we already have that statement there. So now that we've done when x goes to the left, let's send x to the right. So x is going to the right. Well, f of x is going up. So as x goes to the right, then f of x, which is a fancy word for y, goes up. That's all we're saying here. Alright, now the tricky part is taking these words and rewriting them as mathematical statements. Whoops. Alright, so as x goes to the right, the way that we express that is we would say as x approaches infinity. Alright, as x approaches infinity, which makes sense because the x values are getting bigger. They are approaching infinity. And as x goes to the left, well then we would say as x approaches negative infinity, because they're getting smaller. Okay, these statements always come first. We always start with as x approaches infinity or as x approaches negative infinity. Alright, f of x goes up. That's a fancy word for saying y. Well, since it's going up, the y values are getting bigger, so we would say they are approaching infinity. Same thing here. F of x goes down. That's a fancy way of saying, or I'm sorry, the fancier way of saying that is f of x approaches negative infinity. Just means it's going down. So if we write this properly, then I would say as x approaches negative infinity, f of x approaches negative infinity. And as x goes to the right, then f of x is going up. Well, I would say as x is approaching infinity, f of x is approaching infinity. Alright, take a moment and try this one on your own. I'll let you pause the video around here and get started. Alright, so the solution for this one, if I start with the dot, start in the middle, and I go all the way to the left, I'll see that my y values are going up. So I would say as x approaches negative infinity, f of x approaches infinity. And let's do as x approaches infinity, same type of thing. I move it all the way to the right. Well, as x is approaching infinity, then f of x is approaching infinity as well. So, it looks like both arrows are pointing up, in short, is what I'm saying. Boom! Alright, that's how we solve these types of problems. I encourage you to practice the problems I've been giving you in class, and I hope that this video has been helpful.